this next video, I'm going to do some road reconstruction, or more specifically, a curb replacement project. So this road is an existing road, and I have a number of different alignments. I have one alignment that represents the existing crown, and I have another alignment towards the left which represents the location of the new curb and channel. And I have another alignment on the right hand side, but I don't think I will use it in this project. I also have a polyline that I've just drawn, and I'm going to later turn that into an alignment and show you how when you use the curb return command in civil site design, you can reference geometry that you've created yourself. So let me just open up the template editor. I have a template called road 3 meter half road, and you can see that we have codes created only on the left hand side. Remember, the center line code represents the alignment that you're anchoring the template off. So in this case, I'm going to use the existing crown as that anchor point, and I'll apply the template off it. But what I want to be able to do is independently design my new curb and channel. So in order to do that, I need to create a string where the new curb and channel is so that I can independently adjust the levels. But I'm also going to show you some aids to help you come up with some suitable crossfall off the road. And one of those aids will be design constraints, which I think for road reconstruction are absolutely fantastic to use. Not essential, but you'll see how they become a great aid to the design. So to get started, I'm going to create a road out of this alignment. And another reason why I'm creating it as a road string is so that I can use the auto curb return command to build this intersection, because we have an intersection between this road and the existing. So I'm going to go and create a road string, and I'm going to apply the half road template and then click OK. So with the vertical design of the existing road, what I'm going to do is tell the software to match the existing levels, the existing surface, but maybe lift it up 50 mil. We'll do a bit of an overlay on this. So anytime you want to automatically design a profile, you use the auto profile command. And there's some really useful tools in here. I'm not going to go into all of them now, but the one that I want to use is called reference surface. So I'm going to tell the software for the whole length of this road, match the NS surface. If I wanted to, I could also apply a fitting so the software will smooth out the design with some vertical curves rather than having an IP at every chain inch. If I click on apply exit, you can see the software's done that design for me. Actually, I did say I wanted to lift it 50 mil, so I'm going to go and edit that, and we will use fitting, but I'll just say raise it 50 mil and then apply. Right. Now we have that automatic design created with the fitting. Okay, so that's the crown set up. The next thing I want to do is, as I said, create a string out of this alignment so I can independently adjust the crossfalls of the curb. So this time I'm going to run the profile string command. Now profile strings are really handy. You can use them not only for what I'm using it for, and that is independently adjusting the levels or offset of a code, but you can also later use them for modeling, modeling islands and that type of thing. But anyway, in this case, I'm going to run profile string, click on the alignment. So I know that this string type is of profile because it says here string type profile. The name of the string comes from the alignment, which I've named new LEB. So I could apply a template to it, but in this case we don't need to because the codes are driven by the template applied off the crown. Sampling the natural surface. Now, in regards to the sampling, if I had set up extra sampling along the road, maybe where there are driveways or other features, I can actually tell the software to use the same sampling as the road. And that's pretty straightforward. All I do is I select on from other strings and say existing road crown, only use these changes, which means that the standard 10 meter section won't be used. The section sampling will come from the parent string, in this case the crown. So I click OK, and the vertical grading editor appears. Now remember, the software just does a designer best fit along the profile. And remember, we're looking at the profile of the curb. So there's a couple of things I want to do. Firstly, I want to set up design constraints because they're really easy and really helpful. To do so, I click on design constraints, and firstly I select the type of design constraint that I want to add. Now there's a number of different options here depending on whether you just want to project some information or you actually want to show a string or surface data. So the first three allow me to project using design levels from an alignment, project design levels from a code, or project from surface levels at an alignment. I can show another string, I can show surface data at an alignment or at a code. So what I want to do here is I want to project levels from the center line of the crown. Now, I actually could use either project alignment or project code, and I'm just going to use project design from alignment. Hit the green plus to add a new one, and I'm just going to call this one road crossfall. So, I fill it out. I want to project from the crown, at the crown. Normally these are the same. And I say, maybe show me -2 and -5%. Pick some colors. You can always turn these off if you want, and then select apply. So what I have are two bands, purple bands, pink and purple, and I know that if I design my levels between those bands, I'm going to achieve suitable crossfall from the road. The other cool thing about these constraints is when I add IPs, I can actually reference them. So from the Home tab, we have IP reference, and those design constraints exist in here. So when I add IPs, there are options to snap to whatever the constraint is set to. So I can snap IPs onto those constraints. So let me just delete those. Now the other thing you can do, going back to auto profile, is I could automate my design by referencing one of those constraints. So I could say, well, for the first 20 meters, match down to one of those constraints that I've created. So design constraints are really handy, and you can also see them in cross-section. Now, what I'm going to do is open up a cross-section for the design. Okay, now the first thing I notice is the template is the batter's not appearing. Now I can confirm the batter just by opening the design data form. So I'm going to click on design data form, click on the string. Sorry, I want to click on the string for the main road, existing road. Now I can actually see in here that there's an entry for batters turning it off. Now, batter overrides are really cool. Basically allows you over certain change ranges to override the batter. Maybe you don't want a 1 in 4 batter over a certain region. You can also transition batters over regions. So really useful, but in this case, I actually want to delete that entry, which turns off my batter. And you can see my batter now appearing on there. Now, I've got a very uniformed -3% crossfall from the crown. So at this stage, I can tell that I haven't actually matched the LEB to the string. So a couple of things I want to do. Firstly, I want to turn on the string information. So I want to say on all roads, show me the new LEB. That's just the level. And show me the alignment of new LEB. And the beauty of adding this to the cross-section view is just gives me confirmation that my edit is correct. Now, it might be a little bit hard to see, but I have a blue line indicating where my alignment is. It actually just so happens to appear exactly where I want it anyway. And this red dot is the level that's currently on the string. So what I want to do is tell the software to match LEB to that string. So I right-click, click on Add Variation, Modify Section, and I want to match code to string. There are a few different methods, but 90% of the time you're going to use change offset and level, and I want to match it to the new LEB string, and then click Apply. So now I've got that varying crossfall, and if I was to go and open up the vertical grading for my new curb, this yellow line indicates the current cross-section view that I've got open. And if I just lift this IP up, you can see the crossfalls changing. Alright, and remember, if I design it between those bands, design constraints, I know that I can achieve, the suitable crossfall. That's the benefit of those design constraints. Okay, so that's the first part, and obviously we could play around with that string to get the levels right. There's a whole bunch of stuff that I would do in later videos, like showing you how to add laybacks for driveways, and maybe even doing a driveway check using the driveway tools to make sure that the cars are going to be able to enter. But the next thing I want to do is just set up the subbase. Because at the moment I have full depth pavement running from the crown to the curb. But what I want to do is show full depth pavement maybe about 600 mil out from the curb, the lip of the curb, and then the rest of this will just be, I guess, a resheet. Now, in order to split up the subbase to have different regions, I need to add a new code. But I don't want this code to affect my crossfall. I just want this code to sit on top of this section. So what I do is I right-click the mouse, add variation, insert, and I want to insert a section that interpolates a level off the section. So it's going to be positioned before LEB. You know that because that's where I click the mouse. The new code will be LSAW, and I'm going to say relative to code 0.6. Now I could position this code off an alignment, so some people draw an alignment for the saw cut and tell the software to add the code to it, but this will just be a fixed 600 mil from the LEB. So I click on apply. The code has been added, LSAW, but my sections have been broken. I don't have any subbase here. Now subbase is handled in the template editor. And remember, I'm working with 3.5 meter road. Now, at this point in time, LSAW and LEB don't exist. So I can't just go edit section and edit the section because you can see LSAW doesn't exist at this point in time. So what I'm going to do is use subgrade by codes. I click on set subgrade and I say that I want to add a region between centerline and LSAW. And this is my resheet. So I just put like a nominal depth and we'll just say asphalt for for now as the material. But I want to tell the software that this layer will match my surface. So I click on Assign Layer Controls, and here it lists all the layers. You can have up to 10. So I'm only interested in the first line. The first few columns relate to extending the subgrade out beyond its section, so I'm not interested in those. All I want to do is say that this depth will match the surface, and we'll give it a minimum thickness of, say, 0.05 and a maximum extra depth of 1. So apply and exit, and that's that setup. And the next thing I want to do is set up the subbase between LSAW and LEB. So first code is LSAW. Remember, you're always working out from the center line. That's why LSAW comes first. Now this will just be my standard pavement. So if I go and click OK, you can see there now that we have full depth pavement out from the curb, and then I have this sort of resheet layer, but the crossfall is still as per what I've set up. Okay. Okay, so the final thing I'm going to do is just fix up this intersection. I need to add some curb returns in. So at the moment, I just have a polyline, and I'm going to turn this into a civil 3D alignment. And I'm going to call it new curb return. Click OK. And I'm going to add a curb return for either side. Remember, this one will reference the alignment that I created. So I go to Network Strings, curb return, click on that section, and I tell the software that I want to use an alignment called new curb return. It's really as simple as that. If I click on Create Update, then the software will model the curb return using the geometry that I've set up. Really quite cool. So then I'm going to add another curb return up the top, and we'll just go for a standard 10 meter radius on that one. So this is just a really simple run through of a curb replacement job. I've set a point that I want to anchor the design off, and in order to independently change the levels of a code, in this case the lip of the curb, we can create profile strings, and then we attach the codes to the profile strings, which gives us the varying crossfall. Now, as I mentioned, the other cool thing, useful tool, are design constraints, because you can set up as many of these as you want for a string, and they are really useful for aiding the design to ensure that you're achieving suitable crossfalls.